full screen did like letterboxing.
It is readable, right. So
let me here, let me just proper full screen. I'll just share my whole window instead. I think that'll be a little bit easier, because there's some little bits of code in here that might be a little bit small. Is that any better? There we go. Cool. So we're going to talk about the Lightning Data Service, and specifically, we're going to talk about the Lightning Data Service with Lightning Web Components. I am Tom Dalbo. The Twitter link on the Trailblazer meeting invite is dead, so I do not have social media, but I am in the Discord, so I'm going to keep plugging that too. It's a great spot, a good way to collaborate. Usual Salesforce-y stuff, because I do work at Salesforce. So anything that we talk about here, yada, 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 don't make any purchasing decisions based on what I talk about, and just make things based on current product availability. But yes, so we're just going to jump right into it. So what is the Lightning Data Service? What has it been, and what does it continue to be? So we've got a little bit of history here, and I shamelessly just yanked this out from our product documentation. Aura, when Lightning was first kind of envisioned, and what, 6-7 years ago, give or take, there was an emergent need to have the ability to have data state consistency on these shiny new single page apps, right? No longer were your front end apps being completely server driven. They were now being client driven. And it was pretty obvious that there needed to be a way to keep all of this stuff through a single centralized layer. So you didn't have, for instance, 10 different parts of your UI asking for the same thing, and then all having 10 different copies of that same thing, and then all having to worry about updating it and fetching it and managing them all themselves separately. It's chaos. It's a nightmare. It's 8 years ago, right? And so Aura needed Lightning Data Service. And so Lightning Data Service came out of that need. And here we have this force record part in the middle. Force record data is is a way to, just for example, get a record from the Lightning Data Service in your Aura component. And so here it is. It works. It's fine and dandy, and it is very much still out there and very much still works. And so all that documentation, everything for all of your Aura-based stuff, this is how you're going to interact with Lightning Data Service. Awesome. That's not actually what today is about, though. If you are still in Aura world, or you have a set of mixed components, Aura and LWC, this is great. This is viable. Go look at the documentation. But we're going to be more future thinking and future forward in this talk today. And so we're going to talk about LWCs. And so LWCs, and again, this isn't really talking about LWCs either, but at a high level, right, Lightning Data Service through LWC allows you to access API data through your components. So it's a client-side data broker for APIs. It acts as a client-side data cache. It has data normalization and denormalization. We will get to that later and what that means. It has UI API and Apex support. So when you go look at the documentation, and I'll have links to all this at the very end, you'll be able to see how you can access those endpoints through your components. And then what we talked about before, sort of the reason why Lightning Data Service existed in Aura and needed to be written, still is true today, right? We want to make sure that we have data view consistency, and we also want to make sure that if these 10 different components on your UI are all kind of asking for the same thing, or similar sets of things, or overlapping things, they actually have the same thing. That's really important. And then, as kind of a sub point to that, we also need to make sure that when stuff is updated or stuff changes, those things are told that there's an update and they are given that new data. And so that's all exposed to your LWC component via @wire. So let's talk about that. And by the way, I'm going to take a bit of a break between these segments. I have a few segments throughout this, but I definitely want to have like Q&A and discussion and sort of lively active. So put your questions in that Q&A section of this thing, you know, in this UI thing over here in the chat thing, whatever. And we'll go through all those at the end. So I definitely want to, you know, make sure we have plenty of time for that. Okay, so the wire service. What is the wire service? The wire service is a protocol for pushing data to LWC components. It uses what is called an at-wire decorator. A decorator is the LWC way of sort of annotating or shorthanding certain bits of built-in functionality. So when you write this decorator in your Lightning Web component, then the Lightning Web component compiler can like understand and do some stuff with that. So it's a nice way for you to have like sort of a convenient shortcut to access pretty great functionality. Data from your wire is always a tuple, and the properties that you have to interact with, if you choose to, are going to be a data property as well as an error property. We will show that in a minute. And it is descriptive, not prescriptive. So at-wire describes what your component needs, but it doesn't like say how to go do it. That will unlock a lot of power later on, and it give you a lot of elegance and sort of sophistication with relatively low amounts of verbose code. So you've got two inputs. You've got a wire adapter, and then you've got an adapter configuration. So that's what you have to tell your at-wire what you're going to be doing and how you're going to do it. And it's going to be, again, the adapter itself, and then the configuration that tells the adapter how to go do stuff, but not really how, because again, you're just telling it what you need. You're not telling it like where to go. It'll make more sense with examples. And then lastly, it supports dynamic values from component instances. And so you can use a wire adapter and you can say, I need this account, and you know, you pass in the account ID and maybe some fields that you want out of it, and then that will return your data. And then you could use some of the fields that you asked for on that account and pipe that into another wire adapter for its configuration, and that gets really powerful. So let's kind of walk through what this looks like. So you've got your imports at the top. This is like the basic of most basic Lightning Web components. It is very straightforward. It doesn't actually do anything, but you've got, you know, you're importing the adapter get record at the top, and that's a Lightning Data Service adapter. And then you've got your component definition, and you've got this at-wire. And so the at-wire, like I said, passes in the adapter and then the configuration. And so in this case, record ID is going to be what we're going to pass into the configuration. And this is just going to basically fetch the record with record ID, like super straightforward. And then it'll store it down here in this record property. And that's it. I mean, that's the most bare bones fundamental. How do you interact with the Lightning Data Service in LWC? Everything, for the most part, builds on top of this. So again, very little code, very powerful. And so what happens when it comes back? So the wired data can be put either into just class property, which we saw before, or a method. And there are some pros and cons with both of these things, but the property usage is like super easy, and it is just very straightforward, and it is just there, right? And it will always update whenever we get new updates from Lightning Data Service, which, spoiler alert, we'll also get into that a little bit later on. And it is just, it's very simple. The method approach gives you a lot more control over the data that's coming back, and arguably more importantly, allows you to handle, or requires you to handle, errors that come back. So for instance, if you pass in a configuration that is requesting a record that maybe doesn't exist, or something that you might not have access to, or whatever that may be, and an error comes back from the API, when you're using the method usage, you will be able to actually do something with that error. And that is actually quite powerful, because then, for instance, if you want to show a form of that error to the UI, you can do that. If you want to perhaps like change something that you were passing into the configuration based off of that error state to possibly make that request work again, that could also be something you could handle in this error. So you've got, again, these two different approaches. So it depends on what you're trying to do, which one you choose over the other. But again, either way, super powerful. So this is what it looks like when you're actually handling it with a method yourself. And it's, again, very, very, very similar to what we saw earlier. But the difference now is this handle data is a function that you are going to then be responsible for doing something with the data or the response. And so you'll either get a data property or you get an error property. And so the data property will allow you to essentially do something with that data that you maybe would want to sort of massage it or change it or modify it or do different things with it, instead of just setting it to a property itself. And then, like I said, as a result, you also need to check for errors. And so you'll do all of that within this method. Okay, so here's some tips and tricks with the wire service. Wire adapters will automatically connect when your component connects and automatically disconnect when your component disconnects. What that really means is you don't really have to worry about it. So if you're using @wire, which you pretty much have to with the Lightning Data Service, with some few exceptions, then you will get all that for free. You don't have to worry about like, oh, well, is component connected? Is the UI state ready? Like you don't have to like do all these little if checks and things like that. You don't have to worry about callbacks. You can just trust that the @wire will handle when all of those happen. That lifecycle management is done at a layer that you don't need to worry about. And so when it's ready, then it will make sure that all of that stuff, all those adapters are connected at the right time. You just have to write this. So that's really powerful and convenient. Okay, wire service with properties are fully statically analyzable. This actually doesn't really have a huge amount of impact on if you are just a Lightning Web Component developer, but this gives us a lot of power to be able to do some optimizations on our end, so we can better serve your UI, and it has implications for mobile stuff like that too. Your component should expect new data from wire services at any time. This is just how the wire protocol works. Single data pushes are rare, and you shouldn't rely on just like, oh, well, I'm just going to get one thing of data back from my wire and that's it. You should expect data to kind of come back relatively often. And we'll explain how that could happen in this next section. But it definitely takes, I think, a bit of a mindset shift, because if you are accustomed to just imperatively calling an API, then you're going to be like, well, I have to call it again, right? And with Wire, you don't have to worry about that. You just have to, again, just tell Lightning Data Service how or what you want the data to look like, and then it will make sure that you get the fresh data all the time. It'll make sure that when something else may have updated in the UI layer, that you and that data is updated, you'll just get the new version of that. It will handle all of that kind of stuff. But you should also expect that. So, when you're writing out your UI and sort of your UI logic in your flow, then you build in this expectation that that data can change whenever. And then lastly, wire adapters will not fire with incomplete or invalid configurations. So you can use this kind of as a tool to essentially wait for certain wires to not connect with data until you want them to. And so this can be used, for instance, say you've got the earlier example we gave, you've got two wires. The first one is requesting a record with like an account, and you want the second one to basically go out with information from the response of that first one. Well, that second one inherently has an incomplete configuration until you tell it to have enough information to then be complete. Then it will be able to go off and do the usual stuff. So that's a bit of a trick that you can use for this wire stuff. Again, very, very little code, but a lot of power and control. Okay, so I'm going to pause here for a second. I think the way that we're going to keep doing this is just Q&A in the chat and then questions, and I'll answer stuff in the end. And I can jump back to these different slides. But this is kind of like the second half of what we're going to be talking about, right? So we talked about wires and web components and how you interact with it. But now we'll talk about the data service itself. All right. So the Lightning Data Service, as we saw earlier, it's a client-side data broker for APIs. It's a cache, data normalization, denormalization, and it supports UI API and Apex endpoints. It also ensures data view consistency, and we talked about why that's important. So what does this look like? This looks like a bunch of boxes in an architecture diagram. So this is really just another way to visualize the whole flow of how this works, right? So you've got your component at the very top here, and we've talked a lot about that part right now, right? You build out your web component, you put your @wires in there, but then it's like, okay, then what? So the Lightning Data Service itself is after that. So we've got this concept of different adapters that are built out to be able to do things and handle and understand these requests or these configurations that are being sent down through these wires. And so you've got a bunch of different families of adapters. These so far are just a couple of the ones accessible and available to you. It's all in, again, the documentation. I'll have links at the end of that. But you can do record stuff, you can do lists-based stuff, although that one's deprecated, but you can still use it for now. Object infos, you can do Apex, you can do analytics wave stuff. There are a bunch of really cool adapters that you can tap into through this @wire decorator protocol. But now these adapters, they kind of just know how to understand what you're asking of them or what you're telling them or describing to them, but they don't actually manage all of the state. So within the Lightning Data Service, we have this other layer that's sort of a store. It's a centralized store. And what the store does is it handles understanding all of these different things at a much deeper level and actually knows what the data itself looks like and is structured as, and it knows what these data structures will come back from the server as well. And so with this deeper understanding of what the data looks like, we can actually flatten out a lot of these different requests coming from different adapters and different components into a centralized store. And this is very powerful in the next example I'll give you. And then the store can actually know how to then reach out to the proper endpoint. It'll basically convert the configuration and what's being asked of it into proper RESTful requests that we then hit back into our server. Okay, so this is kind of obvious, but it's a good way to sort of paint the flow of how this works, right? So you've got your LWC, you've got your configuration, which is just record ID foo. We're just asking for whatever. And then you think, all right, so I've got this configuration. It's going to go into the store. The store's like, well, I need to go ask for it. So then it converts that into the REST request. We hit our network layer, and then it comes back. Hand wavy magic happens. The store does a lot to generate what we call a snapshot, which then will be sent back down to your get record request. And so this seems like a relatively straightforward, oh yeah, well, you're just making an API call. And at the end of the day, that is what this is happening. But there's some, again, super magic stuff that happens right in the middle in the LDS store that can make it such that we can do some pretty cool stuff later. So for now, fetching a single piece of data, it is relatively straightforward. The snapshot part is nice because now that we have this data store, right? We've gone to the network, we've gotten this data back. Well, what do we do with it? And so what we do is we make just a snapshot, a moment in time immutable copy of that data. And we then will be able to understand and send what that original component has asked for back to that component. And so we have to do a few things here because, again, this is the simple case. I'm going to go back a slide here. This is the simple case. This is just one component asking for one thing and getting back the thing it asked for, right? But now imagine you're going to be multiplying this out to quite a few different components, and they're all going to have different varying sets of overlapping requests for certain data. It gets a little more complicated. So this data store part in the middle needs to do a little more work to make sure that it sends the right components, the right things based on what they have asked for in the first place. So we track each resource for updates. Components will automatically get new data when this underlying resource in our store changes. And then we emit this stuff, these snapshots, back through the wires, and they can be rebuilt through the cache. And so I'm going to go back again. Simple flow. And since the cache, say we just loaded the page, right? Whatever, the cache has never seen this record ID before. We've never been asked for it. We don't have it. We go to the network. We have it. Now we cache it. And so when we are asked for anything for this record again that we know we already have in the cache, well, that way we can just immediately serve it. And that is fast. It's extremely fast. And it saves a lot of extra compute overhead, both for us, for our servers, as well as for you and your client, the web browser. It's a much better way to do this, especially if you talk about scaling it out to dozens of components that otherwise would be asking for every single thing as a separate request. So this caching part is sort of the magic here. And so what LDS does is it knows the data at a deeper level. And I mentioned that earlier, but it essentially, it doesn't just say, oh, well, you asked for this URL for a record with maybe some URL params and some options, but that's kind of not the same URL as what this component asked for, so they're not the same thing. That doesn't really work when you want to have this deeper understanding and then be actually able to serve cache responses back to different components. And so the power of this is now when we're caching at this deeper resource level, it doesn't matter how they got into the system. As long as we know that they are the same thing, the same underlying root data structure, then we know that we can emit back to wherever they were requested for. And it doesn't matter how they were retrieved. And it doesn't matter what endpoint they were hit from. And so that really allows us to, in this example, and we'll visualize this in a second, you can have a get record, you can have a get list UI, and a get list UI might return a record that has also been asked for through get record by a different component. What does that mean? That means you've got a record and it's the same record. And so this really allows us to crank up the performance of the UI as a whole, because now you've got one entry for this record, and this record is the record. It's in the data store. And now whenever someone is asking for that record, whether it's through a get record or any different adapter, if it's this record, then we can serve that. And so that really helps, again, like I said, data state consistency, but also save you a ton of overhead, both on your client resources, like your computer, your web browser, your mobile phone, whatever, as well as our server can then be more freed up to serve requests better. And so this is kind of how it all comes together. So now we're putting this cache question in here. So Same thing as we saw before, but now if we already have it in our cache, then we can just generate that snapshot and it's done, right? And that's, orders of magnitude faster than having to refetch back from the network. All right, so this is where it all comes together. You've got your component. We're very familiar with this picture at this point. You've got this get record component, record ID foo, never seen it before. So it goes to the network, generates a snapshot, and it returns back to the component, right? And now we've got this other component over here, and this is a list UI. So it's looking for this list view. This list view is going to be this just arbitrary list view, and it's going to do the same thing for it. So it's going to be like, all right, go to the network, go back, generate a snapshot, and I'm going to return the data that this component asked for, right? So far, these things seem kind of separate, right? You're like, yeah, duh. One thing's asking for this and one thing's asking for a separate thing, and they're getting separate responses. However, say this list view has record foo as part of the list. So now we've made that first request for record ID foo on the left. We made a second request for getlist UI on the right. And say that this record has updated at some point. Say you asked for some fields and someone changed the name of your account or whatever it might be, right? So now the response that came back from the network includes that updated record. The LDS store will take that record, it will normalize it, it'll make sure that it ingests it, pulls it in, and now it's like, oh, hey, wait a second. I've been asked for this one before. I'm going to go give this component an updated version of what they asked for. And the component doesn't have to ask for this again. This is all through wire protocol. So the wire service will make sure that they get this updated data, and it just happens. So now, again, we don't have two copies of this record ID foo in our store. Record ID foo was just updated. And that's really powerful. So now this is a simple example. And imagine just how much more complicated this could get with way more components and way more layers of nested data. I mean, I'm sure that you all have some pretty wild schemas in your custom schema. It can get pretty intense. And so that's where this complexity, and allowing the Lightning Data Service to do this heavy lifting of understanding and caching this data at its level helps you write your components without having to worry about any of this. Okay, so that's the big thing. This is kind of like just a sort of side note here. Imperative adapters do exist. The vast majority of LDS adapters are usable through the wire service only. Apex is an exception. You can do Apex calls read-only. There are some nuances to Apex which are more eloquently described in our documentation, but essentially when you do ask for something through Apex, even if it is going to be a record or an account or whatever, we only know what that Apex call is. We don't really know that Apex, we can't do the whole data normalization, denormalization like we do with everything else. So that's a huge caveat. So if you can use something through the UI APIs with LDS adapters, it is preferred to do that because then you get all the benefits and power that we just talked about. Okay, and then create, update, delete adapters are imperative. It all kind of goes through the same stuff in the LDS store. You just call it differently because you can't really wire an update. It's kind of like a thing that you do, right? You just call it and then it updates and then that's it. So it's different enough, but it's again relatively straightforward. Imperative LDS adapters return a promise that resolves a snapshot instead of just resolving, like just returning the snapshot through the wire. So this is what it looks like, right? So you're going to import create record, and this is an imperative call. So we do have to wait for in the LWC lifecycle for the component to be connected. And so once connected, you can just call create record, and you're just doing it. And you still pass in a configuration and all of that, but it's a different path to get something done. But again, the vast majority of LDS adapters are read adapters, and so you'll just be using wires for them. That's it. So if you want to screenshot this or just Google it, this is everything from this slide deck came from these three, or really these two, the first and the last documentations. The middle one is LWC recipes, which is kind of cool. You can go clone that repo. You can then like spin up a scratch org, whatever you want. You can deploy LWC recipes, and you can actually try out all of these things. So we have like very specific sort of like sample components that you can sort of click around and see how it all works. So there's a whole data service tab that really shows what we just talked about here, but actually in your org. So kind of all comes back together. And that's it. So we have plenty of time for questions and answers, and I really hope that you all have a lot of good ones because I know I went through a lot very quickly there. And so let me know if you need me to jump back to any slides. You know, we'll just kind of do this, I think, free form. I don't know. Patrick, how do you want to do this?
Enough group that I think freeform is good enough. And if you don't feel like talking, don't want to hear yourself talk or whatever, feel free to ask them in the Q&A tab under chat. And Jeremy's asking if you have a link to the slides that you can provide.
Yeah. No. We might have to publish that afterwards. Right now they're I think locked away in my internal Google account. I don't think I have a way to share them publicly.
If you join the Discord, Tom will gladly give them to you later.
There you go. Join the Discord. I'll figure it out.
So Sadiq is asking, is LDS cache stored on the platform or client browser?
Good question. So we have, in the whole platform, in the whole stack, we have a lot of different levels of caching for different things. This specifically for the LDS cache is client side only. And so the reason being is we're a very client-driven application for the very last UI layer, as opposed to like the old world of Visualforce sort of server-side driven UI. And so this data cache really only starts for the most part when you open the web browser.
Quick follow-up question, if I may ask.
Yeah.
Let's say in some cases, right, we might don't need cache, right? So in such case, I need to explicitly get a latest record from the platform. So how do I do that?
Yes. So then that's a relatively common question. You don't have to necessarily worry about that. You can kind of trust the Lightning Data Service to have the latest version of a record. And whenever you are, whenever you wire your data up, you'll just automatically get however many updates that there are to that record, if, this is a caveat, if the Lightning Data Service knows about those updates. And so we don't really have a way to completely piece together everything at the moment. So if there's something that has been updated outside of what Lightning Data Service knows about, it doesn't know what it doesn't know about. And so it doesn't know to go fetch the latest updates for those types of things. But for the most part, for the most common is the most what's the word I'm trying to think of? Well, the most usages for this, just using Outwire should be sufficient. There are some edge cases in there, and I can link you to some documentation that can kind of
I faced
walk you
few
through
scenarios.
that.
Yeah, sorry. I faced few scenarios like where I need to explicitly get the latest update from the platform. I mean, not necessarily it is known to LDS or not. Is there a way programmatically to do that?
There is not at the moment. So like I said, there's not really imperative invocation for get calls. So you can't just say, I need you now to get the latest thing. But there may be some ways that this is a very common.
Yeah. So there is. So think of the Attwire not as a go get this now, which it is not. Attwire is a I need this data, and so that's why there's no imperative version of it, because it doesn't make sense to say I need this, I need this, I need this. So what there is instead is a function called get record notified change, which is a mouthful, but it essentially means, hey, Lightning Data Service, I have some information you don't have, and I think this record might have changed. Please go see if it has.
Yeah, okay. And what is that method you said? Get
record notified change.
Okay. Yeah, thanks. I'll look into it. Yeah, thanks, Mike.
And the world's loudest mouth.
I don't know. I thought my mic is physically muted, so I'm wondering if it's using a different. Oh, that is why. It is.
It is using the wrong mic. That should actually sound better now too.
You do sound better. That's
Yeah, amazing what happens when it's not using your webcam mic.
Oh dear Lord, yes.
Yeah, I had set it up to use this nice fancy mic that I have a physical mute button on, and so that makes a lot more sense.
Crystal clear clicks.
Yep. Any other questions for Tom?